Welcome to the lectures on problem solving and programming in C course. And this is lecture 14, and the title of the lecture is Number and its Reverse. In this lecture, we will learn algorithms for how to reverse a number. And there is something called palindrome. A number is palindrome if the number is equivalent to its reverse. If reversing a number, you'll get the same number, then the number is called palindrome. There are many ways to check reverse a number. We will see those techniques and try to develop an algorithm for that. Converting. So first, see how do we say to before going to the reversing a number. Let us see one problem called converting a sequence of digit to a number. For example, what is this problem? Let me explain this problem. Okay. Suppose, for example, you are given a sequence of digits one by one like this: 5, 4, 0, 2, 3, followed by a sentinel value -1. Then what you need to display is we should output integer number 454023. 54023. So these are individual digits. Digits are entered like this, which is followed by -1, and then we should display 54023. Okay. Suppose if 1, 0, 2, 4, -1 is entered, we should display 1024. Okay. Suppose if digits are 1, 0, 0, then should display 100. Okay. So this is a problem is called forming a number from a sequence of digits. Okay. Digits are entered using the sentinel control repression and the sentinel values -1. So what we can do is in this problem, when 5 is entered, okay, what is the number up to here? What is the number? 5. Only 5. Okay. When 4 is also entered, up to here, what is the number? 54. 54. How do you get 54 from 5? So 5 multiplied by 10 plus 4. 4 is the digit. Okay. When you are here, what is the number? 540. 540. How do you get 540? 54 multiplied by 10 and 0. When you're here, the number is 5402. How do you get 5402? 540 multiplied by 10 plus 2. So how do you get this 54023? How do you get this? You multiply it with 10 plus add the digit. So at each iteration, initially we are starting with 0, and at each iteration you are multiplying your current number with 10 and add the current digit. Eventually, if you do this until you get -1, you will get the actual number. Let us develop the algorithm for this. So we are incrementally computing the number, incrementally compute, because we can't remember these numbers. When your number 4 is read, 5 is gone. Somehow we have to represent that number. So what we will do is, I will keep the number updated based on the numbers already digits already seen so far. Okay. So when only 5 is seen, my number is 5. Only number 54 is seen, my number is 50. Like that, I will incrementally form the number. So at any point in time, I have the number formed by the digits entered so far. Okay. Eventually, when the -1 is entered, I have the number formed by all the digits entered from the beginning to end. Okay. Let us try to develop an algorithm for this. Algorithm. Digits to number. Digits to number. Number. Input. Input. a sequence of digits, digits, followed by -1. -1 is the sentinel value. Okay. Output a number formed by the using the digits in the digits. Begin. Begin. Okay. So we are having, we will have a sentinel control repetition. So we can do a do. So reverse number is initially 0. Okay. Then we will use a do while repetition. Okay. Do. And say, let's say d is equal to 0. While we will use do, and while d not equal to -1. -1. Okay. Okay. Let me read the first digit. The while loop may be more useful. So that's why I'm using while loop. So input D. First D, let's read the first digit, input D. While D not equal to -1 loop. Okay. Maybe better thing is there. Let me see. Let me think. Okay. So we will use a do while loop. Do input D. So D is a digit. So we are using it as an integer. So anything else will be an invalid input. Let's validate the input. If D is less than -1 or D is greater than 9. Anything if this condition is satisfied, it means that it's an invalid input. Output invalid input. Stop. End. Okay. Not stop. I think we should not stop here. We will continue the program. Okay, let's stop. No problem. Let's stop it here. Program will be stopped. Okay. So otherwise, what happens is D is a valid number, but we should not run for minus if D greater than -1. D not equal to -1. D not equal to -1. Then what is it? Number equal to number multiplied by 10 plus D. Our current number is multiplied by 10 and added to the D. So you'll get the next number formed by the previous digit and the current digit. Okay. And while the do while loop while D not equal to -1. Output number. End. Let me explain the algorithm once again. Since we are using a sentinel control repetition, do while loop is a suitable candidate. So initially we have a number equal to 0, and then we read an input digit. So what are the valid inputs for digit? Digits is basically 0 to 9. Since our input also includes the sentinel value -1, So anything less than -1 or greater than 9 is a invalid input. Invalid input, I'm stopping the program. Okay. Otherwise, what happens is this condition is not satisfied. So we got a valid digit. So valid digit, but what we need to do? We need to update the number. How do you update the number? Number equal to number multiplied by 10, current number multiplied by 10 plus the current digit. So a number equal to number star 10 plus d. So this we will do only when d not equal to -1. If d equal to -1, it's we should not do, because that is the internal value. User has entered its internal value. We should break the loop. So by the time -1 is entered, the number contains the number formed by the sequence of digits that we are outputting. Okay. Let us go to the next problem, reversing a number. How do you compare reverse a number? Right. So suppose if 1, 2, 3, 4, 3, 4 is my number, reversal is 4, 3, 2. 2. Okay. So imagine how this number is formed. Number is formed with the digits for the sequence of digit 4, 3, 2, 1. Okay. These are exactly the digits from right to left. Okay, it means that there is a connection to reverse of a number to the previous procedure we have written, previous algorithm we have written. I mean, forming a number from the sequence of digits. We know how to extract the digit from right to left by using a modulus operator, modulus 10. Extract 4, extract 3, extract 2, extract 1. And then treat this as a sequence of digits, 4, 3, 2, 1 as a sequence of digits. And then use the previous algorithm to from the number. Let us write the algorithm. Algorithm reverse input a number n greater than 0, output an integer number, n is integer number, but output reverse of the number. It's not just displaying, we need to form the reverse of the number as an integer number. That is why begin. So input n. So let me copy this. So this is same input validation. We did the input validation. Input n less than equal to 0, then invalid input at stop. Okay. Otherwise, what is my reverse of the number is 0, because we are completing initial first value. In the previous algorithm also, the number formed is started from the 0 only. So that is the reverse of number is also 0. While we need to extract the digits and simultaneously form the reverse of them. While n greater than 0 to. Okay. D equal to n mod 10. Okay. So reverse is equal to reverse star 10 plus d. Okay. So this is d is basically the sequence of digits we are extracting. Then in the previous section, we are also forming like this. The digits will be extracted from the right to left. It means that the least significant bit digit to the most significant digit. So those sequences is exactly the sequence required for the reverse of the number. So that's why we are using those sequence. We are forming the number incrementally. Okay, reverse star 10 plus d. So n should be n equal to n by 10. N by 10, n is equal to floor of n by 10. And y. Right. Output reverse. End. Yeah, that's it. So there is a connection. That's why the first problem is discussed here. So what is the connection? So the connection is this: for the reverse of a number, the sequence of digits is basically exactly same as the digit extracted from right to left. We know how to extract the digit from right to left by using a modulus 10 operation. So 4 is extracted, 3 is extracted, 2 is extracted, 1 is extracted. And incrementally, we'll make 4, 43, 432, and 4321, like that. So this is the logic. This is the logic exactly. Logic. These two statements. Digit extracted, and then the number incrementally, reverse number is incrementally formed. Then to go for the next digit, number is the last digit is discarded. Let us try to write an algorithm C program for this. VI reverse C. Insert hash include cdibo.h int main return 0, return 0. So there is input n. So let us read the input int n printf, enter a number, enter an integer number, enter a positive integer number, nf %d and %n. This is the C statement for input n. Next statement is if statement. If try to observe the way I'm typing the program. This will give you an idea on best how to type. What is the best way to type a program? So n less than or equal to 0, n less than or equal to 0. Output means printf. Invalid in return 0. If statement is over, then reverse. Reverse is equal to 0 means int reverse. Reverse is also integer number, right? So that's why you need to declare it. While loop, while. So you observe. So I first any block I am typing a empty block. While begin bracket, end bracket, and begin curly brackets, end curly. This is my end while, empty while block. So what I will do, I will type like this. I will go here and enter the condition greater than 0. Okay, and come here, enter here. So automatically indentation is happening. You see here, that control comes here, nicely indenting the code. So here, what is the next statement? D equal to n mod 10. D equal to n. Modulus is percentage symbol in 10, right? In C. Modulus operation is percentage. The reverse is equal to reverse 10 plus D. What next? N equal to n by 10. N equal to n by 10. So actually we should write n, algorithmically we should write n equal to floor of n by 10. But in C programming language, since n is an integer, n by 10 will also be an integer. It is exactly equal to the floor of n by 10. So it will describe the fractional part. So that's why you need to use a special floor operation. Okay, we need to display reverse. We'll display nicely like this. %d reverse of %d is equal to %d, comma n, okay, n comma reverse. But the problem is n is already 0, so we need to preserve n here. Int n1 equal to n. So n becomes 0 by the time while loop completes, n becomes 0. So I want to have proper message in the output saying that reverse of 1 to 3 is equal to 3 to 1, like that. So that's why I want to preserve n in the name of n1. Okay, right. Let us compile this program. GCC reverse. There is okay, semicolons are missing. So let us add semicolon. Here semicolon is missing. Okay. D is also okay. D is not declared, na? So declare D here, int D. Okay, now compile. Suppose 1, 2, 3, 4. Reverse of 1, 2, 3, 4, 4, 3, 2. Let us say 1, 0, 0, 0, 1000. Reverse of 1000 is 1 because any zeros in the left side, most significant digit zeros is no significance, right? That's why it will be 1, 1. For example, 1, 0, 2, 4, 2, 5. The number is 5, 2, 4, 2, 0, 1. Okay. This is nicely computing the reverse of a number. So I will stop here. Thank you. In the next classes, we will continue the discussion on different problems on numbers. Thank you.